Researchers in the US have begun building a new particle detector that they hope will help find an answer to a very big question. Just why does the universe exist? The project is known as the Deep Underground Neutrino Experiment, or DUNE for short, and will study subatomic particles. Let's speak to Dr. Mark Scott, Senior Lecturer in Neutrino Physics at Imperial College London. Dr. Scott, thank you very much for joining us. We've got two projects that we need to talk about, one American, one Japanese. Let's start with how the science works behind what you're trying to discover in words of one or two syllables, if you can.
I'll try my best, thank you. Yeah, we're studying a fundamental particle known as neutrino, and it comes in three different types, things we call flavors. So we have electron, muon, and tau type neutrinos. Now these experiments, the one in the US and Hyper-K, the one I work on in Japan, we create very powerful beams of neutrinos and fire them hundreds of kilometers. And when we create these beams, as they travel, the neutrinos change between these three different types. So a muon neutrino may change into an electron neutrino, for instance. And what the experiments are looking for is very subtle differences between how matter neutrinos change compared to antimatter neutrinos. And if we see that these are different, it might tell us why the universe we live in appears to be dominated by matter rather than antimatter.
Why does it have to be so far underground? We're seeing pictures of the tunnelling that's had to go on to enable this to happen.
So the detectors are very, very sensitive. They're looking for extremely rare and extremely low energy events. And the Earth is surrounded by an atmosphere, and it's continually bombarded with particles, mainly from the sun, but also from elsewhere in our solar system. These particles are raining down on us on the surface of the planet. And so if we built our detectors on the surface, they would just be swamped by this background. We call them cosmic rays. And so we dig them underground and put usually a mountain on top if we can to shield ourselves from this.
How is it then that the Japanese-led Hyper-K project is ahead of the American DUNE project?
Yeah, this is an interesting question. So the two collaborations made decisions early on in the design of their experiments, and the Japanese group, Hyper-K, chose to use water detectors as their technology, whereas the US-led group, DUNE, uses liquid argon. So liquid argon is very nice. It gives you a very detailed look at what's happening in your experiment, but it's very hard to get a large volume of liquid argon. And so they had to do a lot more development of their detector, whereas the water technology used in Japan was well understood, and it's much easier to make a larger detector. So the design for Hyper-Kamiokande has, I think, 225,000 tons of water, whereas the design for DUNE has 40,000 tons of liquid argon, so roughly 5.5 times bigger.
Well, they don't call it a space race for nothing, I suppose, and it's an apt description on this occasion. Dr. Mark Scott from Imperial College London, thank you very much for taking us gently through the science. Thank you.
Thank you.